All right, so we have just taken the final exam last Saturday. Today is Monday. Make sure that your name is on your paper. Here's Mr. Sindel. We're recording this because Ben is gone, although Ben got, I think, on every single one of these he got correct. All right, the way that this works is first page is problems from the final that we took. Second page, front and back, are problems related to these problems that I'm going over with you right now. All right, so number 5. We know that this function is twice differentiable, so we can take the derivative twice if we want to. And we have our table. Lovely. All right, so we need to estimate f prime of 4. So down here on part A, f prime of 4 is approximated by. That's what we're trying to do. Well, we need to approximate 4. 4 is right here. 4 is in between 3 and 5, so we're going to use the secant line between 3 and 5. And the secant line's slope is the y1, or I guess y2 minus y1 all over 2 minus 1. So it's the y coordinates first. I have -2, and then I subtract the 4. And I'm going to divide that by 5 minus 3. This again is just the...
Subtract the 4? Oh, God. Okay.
Yeah, it's just... I guess I can write out the formula if that would help us.
No, I think... yeah, it was a little confusion. I get it now.
Okay, perfect. Rochelle, you okay? Perfect. And then you just need to simplify this correctly. So this will be 2, and if you do the little trick, plus the negative, so 2 plus -4 is -6. 5 minus 3 is 3. That reduces to -2.
No, it's 2.
Oh, what am I doing? So bad. There we go. Thank you. See, this is, yeah, I make mistakes too. Sorry about that. All right, -3 is the approximate slope. And then the work that leads to the answer, you need to have that thing and that thing to show your work in terms of getting the points. All right, no questions on A. We're good. We're correcting Mr. Sindel, which is even better. All right, now we need to evaluate this integral. So this is going to be the distributive property going on. This is going to distribute into the 3 and distribute into this 5 times f prime of x. So let's go ahead and write down what that looks like. This is going to be the integral between 2 and 13 of 3 dx minus 5 times the integral from 2 to 13 of f prime of x dx. Okay, what is my email telling me? Something, oh, that arrow shared things with me. All right. So far, so good.
Wait, is the 5 subtracted, or is it multiplied?
That 5 is being multiplied by the f prime of x. I just kind of pulled it up to the outside.
But, okay, so the...
So it's kind of, f is multiplied to f prime of x, but because it's like a constant,
so if
right?
you were to put parentheses, would they be including the negative or just inside the negative? Okay.
Yeah.
Got it.
So those are the two quantities.
So it's, yeah, okay.
And there's the negative sign. All right, so far so good. Now we're going to do these independently. So there's the shortcut trick for this one, which is 13 minus 2 times 3. Do we like shortcut in here, or do we like long way?
Long way.
All right, I'm going to do both. So here's the long way. Taking the antiderivative is 3t evaluation bar from 2 to 13. And then I plug in 13 and 2.
T or X? T.
I think it's t for this
Because
one.
you wrote X for the
Oh,
second
f
one.
of x.
Oh, what am I saying? Oh wait, it should be x.
Yeah, so it should be 3.
I don't know what's going on.
Anyway.
Let's delete that one. I don't think you lose points by switching the variable.
Interesting.
I thought you said it does.
I feel like you would lose points.
For this one, it does depend. Like when you're doing accumulation integrals, you care a little bit more about the letters. On this one, I don't think. Again, I haven't been an AP grader, an official AP grader, so I don't know. This is more of a question for John or Mr. Padron, someone that has actually gone to those grading ceremonies. That's basically slave labor, and it's like that sweat room where you're nice and hot and hating life and grading tons and tons of AP quizzes. And it's not even like you're grading the whole test. You're just grading the same letter or the same number over and over for 8 hours. I think it's maybe more than 8 hours.
Okay.
But then you go to the bar afterwards, and then you have fun, so
No,
maybe...
that's not the solution.
Maybe the end of that is fun.
Absolutely terrible.
All right, so evaluating this thing is going to be 3 times the quantity of 13 minus 2. And again, that is the shortcut. The shortcut method is you do 13 minus 2, the bounds subtracting, then multiply by whatever that is, 3. And you can see that these two are equivalent. And 13 minus 2 is 11. 11 times 3 is 33. So regardless, this thing is going to be 33. All right, now I need to subtract whatever I get over here. So 33 minus this thing. So this is cool. The antiderivative of the derivative, they cancel each other out, but I still have the bounds. So this is how this works. I still have the 5, but they cancel each other out, so I'm left with just f of x. But because it was a definite integral with bounds, and I now have an evaluation bar from 2 to 13, which means I have subtracting 5 times the quantity of f of 13, we'll do giant parentheses here, minus f of 2. I'm going to pause. I really want to make sure that we understand this. Ask me questions at any point along our little journey here.
So, antiderivative of f prime is f?
Yes, because f prime is going forwards, taking the integral is going backwards. Forwards of the backwards is wherever you started.
So how do you know which one to use? So, okay, so do you remember when you showed us, which, I forgot which one it was, but its derivative was the capital F.
Oh yeah, so if I didn't have a prime here, if I did the antiderivative of f without taking, so this is only going backwards. If I'm only going backwards, generally speaking, in AP Calculus AB, that is capital F of x.
So capital F prime is just f of x.
Yes,
Basically the answer.
good. And that's actually how they define it.
Yeah, it was in the thing. It was confusing. Anyway, but yeah.
Yeah, so now I need to actually figure out the height at 13, the height of 2. Well, the height at 13 is 6, the height at 2 is 1, so 6 minus 1. This is now 5 times 6 minus 1. And 6 minus 1 is 5, 5 times 5 is 25. So 33 minus 25, and that should be 8. Is 8? Oh, it's not multiple choice. I don't know what I'm waiting for. I'm like, huh, did we get it right? It is 8. I'm going to assume it's 8. Maybe I should look at the key.
I wonder if we should put units. No, they're really units.
That's not the key. Do I have the key for these guys? I don't know if I do. That's weird.
I'll assume it's 8.
Let's assume it's 8 unless I...
We've already done, then we definitely have 8.
Oh yeah, we should have the key. Okay, let me look back at final exam prep, final 1 solutions, pull that up, go to, oh yeah, so this is from last year. This is kind of cool. Last year, these were what the girls, Kaylin, Sophia, Isabel, Joy, Carly, Rosalie, probably forgot someone.
Wasn't there one guy?
No, it was just all 6 girls. That's why they called themselves the Calculus Queens. That's how they did. Let's scroll all the way down here to lovely. I did not do the solutions to, oh wait, that one was, that's number 5. So that's, wait, I don't know what's going on with these solutions. Those are multiple choices. And then free response, I did not do them. All right. What's going on? Maybe if I go to, oh, that's why. The key. That's what I want to look at. There. Now, these are the ones that I did. I actually have the key in front of me. What question is this? It's not 1. It's number 2.
I have 5.
Number 5. No, it's not number 5. Number 5 was this one. Well, that's number 5 because it's number 5 from the actual AP test. I think it's number 2 on here.
No.
It's not. Did it? Oh no, is this homework not corresponding to the test that you actually did?
I feel like it's not.
I don't think so.
It does not seem.
Oh man, I messed up. I should have given you a different final.
This must probably be from last year.
Let me check if this is from a different final. Because I'm curious.
If so, you just told the answers.
Yeah, but we.
I don't want to give you the answers if this is going to be a final. No, that's the table, so maybe final 3? Because usually there's always like one table problem. So this is the table problem. And that's that table problem.
So do you think it's from last year?
I think it's just from a random, yeah, there's not another table problem. It's still going to be a good review, so we're going to continue with it. I just messed up and given you the wrong final. I should have checked that beforehand, and I did not. I apologize. I really messed up there.
It's funny how you said instead of like wrong classwork, it's wrong final. You know, because it could have been the wrong classwork. Nope.
Yeah, it's not what I should have done. And John even told me, make sure that you do the right final. And I'm like, let's go for it.
Okay,
I apologize.
Well,
Well, let's go ahead and continue doing this. I wonder if we're going to have, These are the same ones from the final, though, because I recognize this one, I think, as I speak too early.
Maybe.
Let's look at number 1. Number 1 is this problem. Number 1 is this problem. They are the same problem. Okay. So I checked I remember checking that one problem and assuming that the rest were okay. Let's check number 2. Number 2 was the same problem. It's just the free response got all messed up.
Yeah.
Okay. Well, let's continue on. So I'm going to assume that it's 8.
Okay.
Let's go on to number C, or letter C. So left Riemann sum. Left Riemann sum means the tail is on the left like this. So the difference here is 1, the difference is 2, the difference is 3, and the difference is 5.
So for the values on top, you take the difference in the values on the bottom, not in left, but on some of them you take the average.
You'll take the average when?
Is it midpoint?
Midpoint, yep.
Yeah, okay. But it's not the difference between them. It's very clear.
Oh, midpoint, actually I think you just take the middle value. It's not midpoint.
Oh.
So check, it's, yeah,
That's the box is one.
the trapezoid.
Yeah.
Yeah, trapezoid is when you take the average of the bottoms. All right, so I'm going to do 1 times 1, 2 times 4, 3 times -2, and 5 times 3. So you can kind of pair these up if you want. 3 times -2, those get paired up. 2 times 4, those get paired up. And 1 times 1, those get paired up. And you actually need to write out your work because you get a point on the AP test by showing your work for the Riemann sum to make sure you're doing it correct. So as long as you do 1 times 1, 2 times 4, 3 times -2, 5 times 3, I think you get a point.
If we just write it like next to the letter C and don't actually draw on the graph, does it count or no?
You have to do it in the little box for part C.
So the stuff you did on the graph.
I'm going to redo
write
it now.
that down. Yeah, okay.
1 times 1, 2 times 4, so plus 2 times 4, plus 3 times -2, 3 times -2, plus 5 times 3. And again, this is a no calculator problem, so we should have 1 plus 8, I guess minus 6, plus 15, and I also got 18 as well. And usually these ask me to indicate units. Does it ask me to indicate units?
I don't see any units.
Nope.
No
All right, so I don't even have to worry about units. All right, and then D. Suppose these things are happening. Suppose that the slope at 5 is 3 and that it's concave down. That's how I read that. F double prime of x is less than 0. It means F double prime is negative, which means it's concave down between 5 and 8. So 5 and 8, what intervals are we looking at? 5 and 8 are looking right here, just between these 4 pieces of data. All right, so use the line tangent to the graph at x equals 5. Okay, so every time I hear the words line tangent, I'm thinking of what formula?
y minus y1 equals m of x minus x1.
Exactly. So we're going to set up that one, and it already gave us the slope, and it gave us the x coordinate. We just have to find the y coordinate.
Wait, what does the first sentence of that problem mean?
Suppose f prime of 5 equals 3.
Like, and then all the way until it says the bounds.
All right,
What is it?
I'll translate every single piece.
Okay.
This says the slope at 5 is 3.
Okay.
So then we're focusing
This
on,
says it's concave down. This doesn't mean anything.
so we're focusing on f of 5, right?
Yes. And in the closed interval 5 to 8, this is telling us that we're talking about this piece of data. For all x is just a very formal way of saying that it's happening. That is important once you're in calculus, or I guess in calculus in college, because in college they are very, very formal about all their proofs and stuff, so they're just being formal here. All right, and so coming down here, we're going to do part D. We're going to set up Rochelle's y minus y1 is equal to slope. We know the slope.
It's 4.
It's 4.
3.
It's 3.
I think it's 3.
It is 3, yeah, it's from right here. Equals 3 times the quantity of x minus x1. It tells us x1 as well. What x coordinate are we dealing with?
5.
5. It tells us there and there. x minus 5, and then we need to find the y-coordinate. So the y-coordinate, I just need to plug in, well, when x is 5, y is -2. Just using the table, -2, so y minus minus 2 is going to be y plus 2. All right, what do we need to do with this? So using the line tangent to show that f of 7 is less than 4. So we're going to use this line. This line is technically a secant line. It's not a tangent line, I guess. Oh, no, that's a different segment. Okay. No, they are different. So the tangent line is only touching once. Secant line is touching twice. All right, so let's first use the tangent line that we just found to show that this graph at x equals 5, that the height of 7 is less than 4. So what's happening here? They're talking about some point 7 in between 5 and 8. We want to show that the height is less than 4. So let's plug in this x-coordinate, 7. Let's use the same x. Let's plug in 7. Let's see what happens. So now it's 7 minus 5. So 7 minus 5 is 2. 2 times 3 is 6. 6 minus 2 is 4. So I get y is equal to 4 when I plug in 7. But there's something else happening. This has a curve. This was not, I mean, this tangent line technically is a straight line, but this problem told us that there was a curve. Is it curving up or is it curving down?
Down.
Exactly. So is this an over approximation or an under approximation?
Over.
There it is. This is an over approximation, which means the actual answer should be under 4, right? If this is under 4, then it's definitely under 4. That's what we're trying to prove. We're trying to prove that that thing that we just found, this height, is less than 4.
But if it ends up to be like 7, then what would we do?
What do you mean?
Okay.
If we didn't get some nice value,
Yeah.
then we have done something wrong. They'll usually give you a nice value. It'll work out. So y equals 4. We'll say that this is an over approximation. And what's our rationale again? Because,
Concave down.
yeah, and how you say concave down, nice and short and sweet by saying f double prime
Is less than 0.
is less than 0.
Wait, shouldn't it be because f double prime is greater than 0 in this case?
No, because if you concave up, then
No, because,
I'm just rereading what they give us right here.
oh, okay.
So f double prime is less than 0. And then what does that imply? This means, we're trying to prove that the height is less than 4. Does this prove that the height is less than 4? How does this help us that this is less than 4?
It proves that it's equal to 4, but just not greater, not less than.
the 4 is an over approximation, which means it's less.
This means that the height at 4, so it's f of 4, is less than or equal to, or sorry, f of 7, I don't know what I'm saying. F of 7, the thing that we're plugging in, is less than or equal to 4, which is what we were trying to prove. That's the first half of part D. The second half is using a secant line. But let me pause. Are we okay so far?
Is part D one that you would like do on the AP test, or you skip it?
You'd probably skip it. Because as long as you've done part A, B, and C, you've probably gotten 6 points if you
Yes.
did them all correct.
Part D is there's like a lot of stuff that I would totally not realize if I was actually trying to do this.
And that's fine, yeah. And you don't need to know this entire problem. As long as you think you can get 100% on A, B, and C, you are more than passing. In fact, you can probably get a 5 just by doing A, B, and C.
Right.
D, I would guess, is probably about 3 or 4 points, just on my experience. I don't have the key in front of me. Okay, now we're using the secant line to show that f of 7 is greater than 4/3. Well, the secant line is just using the secant slope, and we know what the slope is between 5 and 8. We did it. We didn't do it. I thought we did in part A. Part A was doing between 3 and 5. So we need to redo it again. So I need to find the average slope between 5 and 8 again. Do you remember how to do that?
So it'd be like
Yep.
8 minus 5 over 3 minus -2.
You have it backwards. I think it should be 3 minus -2 first.
Oh, yeah, sorry. 3 minus -2 over 8 minus 5.
8 minus 5, perfect. And that's going to be 5 over 3.
Oh, yeah. For some reason, it's over 5. Yeah, okay.
So that's a slope. What's the y-intercept? Or what's the equation, I guess? There's a much easier way to do this. Again, I'm going to be using y minus a y-coordinate is equal to 5/3 x minus the x-coordinate using point-slope form. Caitlin just sent me an email.
Shouldn't it be 7? X minus 7?
It is indeed x minus 7. Ooh, no, we're gonna plug in 7 in a sec,
Oh,
but we need to find the equation before we plug in 7. What is the equation? And just choose a random point. You can choose that point or that point.
Any of the points?
That's how point slope works. It doesn't matter which point you choose as long as it's on that line. Both of these points should be on that line because a secant line goes through those points. That's the definition of a secant line.
but it should be at least 7 because that's what we're trying to find for the slope.
Yeah, we have to put in that.
Or it could be
Choo-
any between 5 and 8, right?
Yeah, and the only things we have between 5 and 8 are 5 and 8. So
Yeah.
choose a random point. Which one are you using? 5, -2 or 8, 3?
Let's do 5.
5, -2. Okay, 5, -2. All right, this is now the secant line. And we're going to plug in 7 into the secant line. Let's do that. 7 minus 5?
2.
2 times 5/3?
Should be like 10 over
10/3. And then this is y plus 2, so I have to subtract 2 on both sides. So subtract 6/3, which is the same thing as subtracting 2, and I get
4 over 3.
4 over 3. That means the secant line is 4/3. Hey, look, it's a nice value because we need to show that f of 7 is greater than or equal to 4/3.
Oh, funny.
So
What if it was what if it was say 6 over 3? What would that mean?
then something has gone wrong. They will always give you nice values for this test. All right, so now, again, we're using the fact that we have the second derivative is less than 0. Is that what we're going to do? Let me think about how are we going to do this. Somehow we need to say whether or not this is an over approximation or an under approximation. What do we know?
It's under, I think.
Why is it an under approximation?
It's under because. Or actually, no.
No,
No, it should be under because
no, I
if
think
it
it
was
might be
over,
over.
if it was
Because if it's no,
No,
you're
'cause
right.
if
It
it
is
was
under
over-
because it's concave down.
yeah, if it was over, it should have said f of 7 is less than or equal to 4 over 3.
Well, no, that's just the problem. But it's concave down, which means the point is like
No, but
it's
for,
like
for
cutting
this
off the top.
for this one, the concave. Oh yeah, I forgot.
So this one you have to be a little bit careful.
Our very formal explanation. Anyway.
Yeah, this is not, it's all over the place. So this one you have to be careful because the concavity doesn't really affect us as much as the comparison between the slopes. Because obviously if we have the exact slope that we're looking for, then we check, okay, were we doing concave up or concave down? This slope wasn't even close. Look, check out this slope, or sorry, this slope. 5/3 compared to the actual slope at 7. What was the actual slope at 7?
No,
Was it 4? No.
it was 3.
It was 3.
3. Oh, it was 3. Okay.
All right, so which one is bigger, 4/3 or 3?
3.
Therefore, if I'm using 4/3, or sorry, 5/3, if I'm using 5/3 to approximate, that 5/3 is way, way, way too small. Do we agree?
No, way too small. But
It's pretty small.
Like comparison to the infinitesimal perfectly slope of 3, I think this one is, the tangent line is better than the secant line at approximating a value.
Okay.
I would guess. So the general way that we want to explain this is that since both the slope, or since this is both smaller than the actual slope, I'm not even going to write this out, but this is smaller than the general slope. If this is smaller, then we need to be bigger. If we need to be bigger, then we are bigger than 4/3. I'm going to move on to the next point because that is probably one point, and we need to spend our time on things that matter more, like number 1. This one definitely matters because it's one of those easy, free points as long as you know how to do it.
Isn't that like describes the whole thing? Easy free points.
This whole packet should be basically easy free points. Part D, I would not call that easy free points. A, B, and C were easy free points.
C is like in a different language, but okay.
All right. Okay, what am I going to do? What house am I in?
Powerhouse.
Powerhouse. Derivative of powerhouse, what is the rule?
Go up and down
Yeah.
and subtract 1 to the
And
exponential.
then you
Exactly.
multiply by the inside.
Yeah, and then it's basically daughter times the dinner.
There it is. Daughter times dinner, and daughter for powerhouse, you multiply down. So 2 times that inner, and then I subtract 1. So that inner stays the same, x cubed plus 1. And then don't forget your dinner.
Which is 3x. To the power
3x
of
squared, yeah.
3x squared. And look for a 6x squared out front because that is what I have out front. It's 2 times 3, 6. None of them have a 6 except for E. Therefore, it's E. As a tiny little note, I don't know how many years ago, maybe it was just last year was the first year, but there are no longer 5 choices for the AP test. There are 4 multiple choice instead of 5.
So we have more likelihood of guessing properly.
So yeah, it's really cool to look at the stats over the years because normally like this many people get 1s, this many people get 2s. The number of people that get 1s is far, far less. Many more people pass and get
Did you
2s.
say that the same amount of, like, if everyone got the exact same score, they would still get the same number of, like, 1s and 2s or whatever?
But now it's harder to differentiate among people because they have less choices to choose from.
Oh.
Yeah. Ideally, there should be, but it does waver over the years. All right. Definite integral, number 2, of e to the negative 4x. Okay. How do I do this?
Taxman, probably.
Why is it taxman? You're right.
Because the thing, X, the thing.
The thing, the inner.
Yes. The inner is not 1.
Dinner is not 1. Yeah. So or the derivative of the inner, dinner is not 1. Dinner is, in this case,
-4.
yeah, that's
Yes.
not 1. Okay, so let's set up taxman. We need a u, we need a taxman, we need a u prime. All right. Our u, our inner of e house is always the power. So our inner, as we all said, was -4x. And we already took the derivative of that, which was -4. This thing we didn't discuss yet, taxman. Who is taxman?
E is 1.
It's 1. So e is part of the house. So what's outside of the house, there's nothing. So we're going to just say 1. And we're going to pay this invisible 1. We can put a 1 right there if you want. We can pay that invisible 1 with -1/4 because this reduces now to -1/4. So my new integral becomes, after I pay taxman, -1/4, the integral between 0 and 1 of, same thing, e to the -4x dx, because I already paid the taxman out front. What is the integral and the derivative of e house?
1 over whatever it is.
No, it's the same.
It's the easiest one. E house is e house. So I'm going to rewrite the same thing here. -1/4 e to the -4x. Evaluation bar from 0 to 1. Derivative and integral of e house is e house. You don't do anything to it. What's the... maybe we'll review the other things later, unless you wanted to do it now. Do you know the derivative of log house, for example?
Then it should be, right? Or no, log house?
Yeah, let's do some quick review. What is the derivative of log house? Let's write it down. d dx of natural log of x. What's the derivative of log house?
The X. Oops.
It's a flip.
What's the fancy
Oh,
word?
Flip the
1
inner.
over X.
Reciprocal.
Reciprocal.
1 over x, yeah. So flip the inside. Done. I like the word flip much more than reciprocal and much more than 1 over x because flip really means if you have a fraction in here, you flip it.
Oh, yeah.
So if I had natural log, for example, natural log of 2 over 3x, then the derivative of this house is 3x over 2. You flip it. And then, of course, you'd have to do dinner for this one. This one, you didn't need to do dinner. I mean, if you want to do dinner, it's times 1. You know powerhouse. What are some of the other houses? Trig house. What's the derivative of sine?
Cosine.
What's the derivative of cosine?
-sign.
Good. What are some other ones? We got powerhouse, we got log house, we got e house, we got trig house. I think that's all of them.
We're probably forgetting.
There's probably one more. Okay, let's come down here. We paid taxman. Now we're doing the evaluation bar between 0 and 1. Let's plug in 1 first. You always do the upper bound first. So, and I'm going to leave that negative 1/4 and not touch him. On the inside, when I plug in 1, I'm going to get e to the negative 4, and then I'm going to subtract when I plug in 0. Plugging in 0, I get e to the negative 0, e to the 0. Anything to the power of 0 is 1. So I'm looking at, like, what is something of this form, and it looks like D, because it's obviously divided by 4, and I have 2 pieces.
Oh, because the negative from the outside multiplies. Yeah, okay.
Yeah, I wasn't actually checking the negative times the negative. I was just looking for 2 pieces where I was dividing by 4. And that narrowed it down for me. But now that I look at it, yes, a negative times a negative should be a positive 1/4, and a negative times a positive is that negative e to the negative 4. Good, good. All right, let's go on to number 3. Horizontal line is the asymptote. So whenever you see the word asymptote, what words should you think? Horizontal asymptote.
Limit as something. Infinity.
Limit to infinity, yes. Limit as whatever x approaches to infinity. So we're doing those top-bottom rules or something like that if we had a function, but it means that when I take the limit of whatever function, and we're calling it f, that means that the answer, it told us the answer. The answer was 2.
2.
So what do we know about the function? F of 0 equals 2. This is saying that the height of 0 is 2.
Well, what you just wrote down is one of the answers.
Oh, is it? Oh, shoot. Okay, well, done. I want to still go through all these choices. This is saying that the height of 0 is 2. No, this is saying that it can never be 2, which is kind of true except for one case. So this is saying that you get closer and closer to the asymptote, which is exactly correct, except there is this type of weird function. Ready? Let's say my asymptote is right here. I can go like this, woo, and then get closer and closer to it. So I can be at that height. So it's almost true, except for that one case where you go through it and then gets closer and closer. So it's not B. F of 2 is undefined. That kind of sounds correct, but it's like if I had a vertical asymptote, that would be correct. As I get closer and closer to 2, I go to infinity. That's the flip version of E, and then E is the correct answer. All right, we understand 3 really well now?
3.
All right, Rochelle, we're good. All right, let's go on number 4. All right, I'm taking the derivative of this. Uh-oh, I have a fraction, which means I'm doing...
Low D high.
Yeah, there it is. Low D high minus what?
Oh.
2.
High D low.
Okay.
All over?
Oh.
Low. That's right. Or low squared, if you want to put it that way. Low squared. All right, so low D high, so it's going to be 3x plus 2 is our low. Derivative of the high, derivative of the top is 2. Minus high. High is that 2x plus 3. 2x plus 3. And that's all going to be multiplied by the low. Derivative of the low. Derivative of the bottom is 3. Nice. All right. And then it's all going to be over low. 3x plus 2 squared. And notice how almost all of them have a 3x plus 2 squared except for E. So E is immediately out. Unless something weird happens, so maybe I shouldn't eliminate it yet, but if something weird happens and it reduces, I just know that it's not going to reduce. So what do I have here? Notice that the difference between all of these is whether or not these x's cancel out. So let's do the x's first. 2 times 3x is 6x. And I'm going to skip the other part. 3 times 2x, and then I'm going to have to subtract that, is a 6x. So I'm going to actually be subtracting a 6x.
Wait, does the 3x plus 2 on the top not cancel out with the 3x plus 2 on the bottom?
No, it does not, because you have a subtraction sign.
Anywhere in the equation? Because the thing right next to it is multiplication. But okay.
Yes, so when everything is being multiplied, then you have permission. When even one thing is adding or subtracting, you no longer have permission.
Okay, fine.
Yeah, that's a good point. So I notice immediately that my 6x's cancel out, which means chunk chunk, A and B are out. All right, now I need to figure out what's going on here. I have 2 times 2, which is 4, so 6x plus 4. And then 3 times 3 is 9, but that negative distributes into each of those parts. So I really have a negative 9. So plus 4 minus 9. 4 minus 9?
It's -5.
Negative 5. Answer is D. Ask me questions. Bless you. All right. Did you get this one correct? You have the test in front of you, too. It doesn't really matter that much. All right, so from here on out, you are doing review problems that are based on those multiple choice questions. You should be able to do these now. Go ahead and do them. I will put an answer key up online. I have to make the answer key this time because this is running out of my answer keys. So I need to go back and redo these nicely, I think.